Welcome to this explainer. We're diving straight into a high-yield review session on the physics of energy. Let's go through these concepts together to get you completely ready for the exam, stripping away all the fluff to find the absolute essentials. Whether you're seeing these concepts for the first time or you just need a really solid refresher, we're going to build a clear understanding step by step. Let's get into it. Here's our roadmap for today. We'll cover the definition of energy, stores versus transfers, the 8 energy types, real-world systems, short versus long storage, and finally, your exam summary checklist. Starting right off with Section 1, the definition of energy. Take a look at this explosion. It perfectly sets the stage for our review, right? Because energy, fundamentally, is about making things happen in the physical world. In physics, we don't just think of energy as some abstract idea. It's the actual driving force behind every single event, from a runner sprinting down a track to a massive burst of heat and light. So here's the absolutely crucial point. Energy cannot just exist doing nothing. If an action is occurring anywhere in the universe, energy must be changed or transferred. It's literally the mandatory currency for getting anything done. If you're asked to define energy on your test, just remember it's all about that change and transfer to make something happen. And whenever we measure that energy transfer, we use a specific standard unit. You know it, the joule, represented by a capital J. This is an essential detail to remember. Honestly, leaving the capital J off your numerical exam answers is just an incredibly easy way to lose points, so keep an eye on that. To give you a real-world benchmark for the test, let's look at a common activity. It takes about 2,000 joules of energy just to walk up a single flight of stairs between 2 floors in a building. Keep that number in your head, 2,000 joules, for a simple, everyday mechanical task. But check this out. Compare that to boiling water. It takes a massive 400,000 joules to bring just 1 liter of cold water to its boiling point. No way, right? That is a monumental difference. It highlights a really great principle for your exam. Heating things up, especially liquids like water, requires a vastly larger amount of energy than just moving everyday objects around. Moving on to Section 2, energy stores versus transfers. Okay, the absolute secret to grasping this material is categorizing everything you see into one of 2 states. Energy is either a store, kept waiting to be used later, or it's a transfer, meaning it's actively moving around right now in the present moment. Pretty much everything we discuss from here on out falls into one of these 2 buckets. Which brings us to Section 3, the 8 energy types. Now, categorizing these core energy types into their specific roles, whether they're stores, transfers, or sometimes both, is going to be incredibly helpful for you. We've got kinetic, chemical, thermal, elastic potential, gravitational potential, electrical, sound, and light. Let's isolate a few key ones to define so we have them completely locked in for test day. Let's do some rapid-fire flashcards, starting with kinetic energy. Anytime a test scenario mentions runners on a track, a moving car, or a falling rock, I want you to immediately think kinetic energy. It is strictly the energy stored due to the movement of an object. Bottom line, if it's moving, it has a kinetic store. Next up is chemical energy. Now, this is a highly testable store. It's found in your daily meals, the batteries powering your electronics, and fossil fuels like gasoline, coal, and crude oil that formed millions of years ago. When a question mentions fuel or food, think chemical. And then there's thermal energy. You really need to pay close attention to this one because it's a bit tricky. See, it acts as a store when an object is hot, but it acts as a transfer when that heat actively moves from a hot object to a colder one. So be sure to read your exam questions carefully to see if the heat is just sitting in an object or if it's actually flowing between objects. All right, Section 4, real-world energy systems. Take a look at this school bus. Honestly, scenarios exactly like this are classic physics exam questions just waiting to be analyzed. Why? Because it's not just one type of energy. It's a whole system working together. It brilliantly illustrates how one single object handles multiple energy types simultaneously. Think about it. We have the chemical energy stored in the fuel tank. Because the bus is moving, you've got a kinetic energy store. The engine makes the bus hot and noisy, giving us thermal and sound energy. The electrical transfer turns on the headlights. As the bus drives uphill, away from gravity, it gains a gravitational potential store. And finally, the heavy weight of the bus squeezing the rubber tires creates an elastic potential store. If we can confidently break down a complex system like this, we are in amazing shape. Here's another incredibly common test scenario, a classic electrical circuit. The trick here? remember to trace the path. You've got to identify the chemical energy stored inside the battery, which is then transferred as electrical energy flowing through the wires, and finally transferred out as light and thermal energy by the bulb. Just always follow the energy from the store through the transfer to its final destination. Almost there. Section 5. Short versus long storage.
For the exam, you need to clearly distinguish between long-term stores and short-term stores. Long-term stores just kind of wait patiently. Think of chemical energy or gravitational potential energy. They can sit there for years, completely unchanged. On the flip side, short-term stores like thermal heat or kinetic movement dissipate quickly over time as objects cool down or just come to a stop.
For example, think about sacks of uncooked rice sitting in a market. They can store chemical energy for a really long time, years even. But compare that to a bouncing tennis ball. That kinetic energy is incredibly short-lived. While the ball is moving, it has a kinetic store, sure, but friction and air resistance mean that ball will inevitably stop in a matter of seconds. Keep that contrast locked in your mind. Finally, Section 6, your exam summary checklist. Here is our final checklist. If you can confidently master these 4 skills, recalling the difference between stores and transfers, describing specific types, giving real-world examples, and understanding storage durations, you are completely prepared to ace the section. No sweat at all. But beyond just getting an A on your physics test, I want to leave you with this massive real-world question to chew on. As our global population rapidly develops and expands, how will humanity manage these vital energy systems? The principles of chemical stores, thermal transfers, and electrical flow aren't just exam topics. They're the exact same mechanics deciding the future of our developing world. Think about that the next time you flip on a light switch. Good luck on your exam, and keep questioning how the world works. Welcome.